Assalamu alaikum everyone, and today we're going to talk about ellipses. So in our last video we talked about how to graph circles and we introduced what are conic sections. Now the next conic sections we're going to talk about is the ellipse. Now this will be very important and slightly tricky too. Let's recall that an ellipse is when a plane is tilted yet still intersecting one half of the cone, unlike a circle which is in the exact plane as the cone. So that's what an ellipse is. Well, in one way anyway. Another way to describe an ellipse is it has two foci and all the points are equidistant to the two foci. Now you might be thinking, how are they equidistant? I mean, surely one side would have to be near one foci instead of the other. Well, by that I meant the points are equidistant to the intersection of the both, and the middle of these points is the center. That's why we don't just say the center. And also, when the foci get nearer, its eccentricity gets lower. Means it looks more like a perfect circle when the two foci get near to each other. Another way of depicting an ellipse is its line of symmetry. The longest would be the major axis and the smallest would be the minor axis. If the ellipse was more like this, that it's taller more than it's wider, the major axis would be its height. That's why the major axis is not fixed, and the intersection will be the center of the ellipse. Now that's pretty much all the definition and terms we have to understand about an ellipse. This is the equation of the ellipse, pretty similar to the circle equation, but the a and b variables are the axes. A is the major axis and b is the minor axis. So these aren't center points as other variables are at the circle equation. So an ellipse and a graph would be something like the bigger axis would be the A and the smaller would be the B. If it was vertical than this, then it will be the opposite, that the x-axis would be the B and the a-axis would be the y. So they kind of depend on the x and y axis of the shape itself. And also this equation will be important. C squared equals to a squared minus b squared, or a squared minus b squared equals to c squared. Now I kind of get confused this with the Pythagorean theorem, but this is not the Pythagorean theorem. Remember that, because this really gets confusing. For me anyway. Now, something in the standard form of an equation of an ellipse, like x squared over 9 plus y squared over 4 equals to 1. So, if we take the square roots of the bottom, we see that a equals to 3 and b equals to 2. Because remember, this is a squared and this is b squared. So now if we plug them into the other equation, that means c will be equal to plus or minus the square root of 5. And this is kind of the center point we're talking about. So the graph, we can plot these points, the minor and major axis. Here would be 3, here would be 2. Now you might be thinking, Uzair, how do I know it's not like it's taller more than it's wider, then it's wider more than it's taller. How is this arbitrary? No, it's not arbitrary, because when the ellipse is taller than it is wider, then 4 would be below x and 9 would be below y squared. So since they're not, but they're the opposite, that means it's here. But if we switch the places, these will be the same, but the equation would be different. Therefore, it's graph. So now it's taller, then it is wider. Kind of like how an oval looks like. Some equations are rather harder, like x squared over 10 plus y squared over 5 equals to 5, but not 1. So we divide the entire equation by 5, and the denominator here turns to 50 and 60. Now, you might be thinking the number got bigger, but no, it actually got smaller, because y is being divided by 2 times. Divided by 6 and divided by 5. Same goes for x. Divided by 10, divided by 5. And we can combine them together. And here it will just be 1, since 5 over 5 equals to 1. There's another way of writing the standard form, that is x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals to 1. Now, does the new variables look familiar? It's from the circle equation when we depicted the center variables. And that's exactly that. So, since this shape also has a center, the h and k would, distort the center and put it away from the intersection. Mostly if it has some value. So in these equations, h and k were 0. So that's all we need to learn about ellipses. Now, this was a very important video about algebra, because when we move on to astronomy later in the future, inshallah, then we will find how planets orbit, and it's not circular, it's actually elliptical, and the foci are close to each other, which makes it look like a circle, which we depicted years ago. But we'll talk about that more in our future astronomy. But for now, we have a lot of math to cover. So, let's move on to our next shape, which is the parabola. So, if you want more videos and tutorials like these, you can subscribe to my channel, you can like, and you can comment, are these videos helpful or helping you or something like that. I really need to know what I'm doing. So, thank you for watching, and I will see you next time. Bye!